Okay, welcome back to the Unit 15 question solving video. So we're going to do 2 of these broken down into questions 1 through 5 in video 1 and questions 6 and 7 in video 2. If you're following along in your textbook, this is page 373. So yeah, let's start answering these questions. So identify 1 and 4 labeled in this cycle. It's provided to the left. So let's look at what number 1 and 4 is. So number 1 is located right here. And number 5 is located right here. So let's break this down. Let's look at what's going on. So number 1, chlorine is staying as chlorine both in gas phase, so nothing with chlorine. The only thing that's happened is magnesium is going from the solid phase to magnesium in the gas phase. If we were to look back at our books or at our notes, we've got delta H of atomization right here is something going from a solid phase to the gas phase. So that's exactly what's going on. So number 1 is our delta H of atomization. And let's look at number 5 now. So 5, what's happening is that magnesium in the solid phase is reacting with chlorine gas in the gaseous phase to form magnesium chloride solid. So, what does this look like too? We've got magnesium in its standard state. We've got chlorine in its standard state. And they're reacting together directly to form magnesium chloride. So to me, this looks like our delta H of formation. Remember, that was to form 1 mole of product from elements in their standard states. So at room temperature, the most abundant state that they're in. So we've got the delta H of formation are what 5 and 1 are. So let's look at a few different values. Let's see what these could be. What is 2? So if we look at 2, what's going on is chlorine gas is being broken up into 2 chlorine atoms. So what this one is our delta H of bond enthalpy. So we're taking a chlorine, molecule, and we're breaking it apart into 2 chlorine atoms. So this is our bond enthalpy. To break that apart, let's look at what 3 is. So what 3 is, it's what we can see here is magnesium is going from magnesium through to magnesium plus through to magnesium 2 plus. So we're going through 2 states, and that's what these 2 values are. Remember, as we take off more and more electrons, that atomic charge of magnesium is going to get stronger and stronger and want to keep those extra electrons more and more and more. So to ionize it once, it's 738 kilojoules, and ionize it twice, it's 1451. So what this is that is our delta H of ionization energy. And then let's look at a few different ones. Let's look at this one right here. Number 4. So what's going on here is we've got 2 electrons reacting with 2 chlorine atoms to form 2 chloride ions. And that's our delta H of electron affinity. So remember how much something wants electrons, electron affinity. So okay, so let's look at this. Let's start by going through number 2. Using our data booklet and the graph to the left, determine the delta H of our lattice enthalpy. And it's nice because it tells us that we have to use our data booklet. But just remember, when in doubt, scroll through your data booklet and make sure that, just make sure that, you're not missing something that's easily provided in your data booklet. So remember how we did this, right? We had to work like a train track. We had to start from the bottom left, work up, positive values go up and negative values go down to arrive at our last value. So this is a negative value going up, but we don't want that. We want to figure out what is the lattice enthalpy. We don't really care what the enthalpy of formation is. So we want to deform chlorine into its products. So our delta H of lattice is equal to plus. We need to start from the bottom and work around to arrive at this final product. So we need to do plus 642 because we had to flip this up. So we had to flip the sign in front of it. Plus 148 kilojoules. Plus, we had to look at what is 2. So we got to figure out what is the bond enthalpy of chlorine. And lucky for you, this is provided in your data booklet. So I've got the, handy enough, I've got the data booklet right here. I just got to flip this, rotate this counterclockwise. There we go. We got chlorine. Chlorine is 242 kilojoules for a chlorine-chlorine bond. So that's 242 kilojoules. And then we need to add 738 for the ionization energy of magnesium, and the second one, 1451. And we got to figure out what this is. This is the electron affinity of chlorine. So we need to add again, right? We keep adding, but we can add a negative number. And the electron affinity of chlorine, it's not provided here, so it must be in your data booklet. Let's go back to our data booklet. We scroll up. As you look right here, first ionization energy, electron affinity, and electronegativity. Electron affinity is provided in our top right-hand corner in kilojoules per mole. Top right-hand corner of chlorine, negative 349. So you've got negative 349, but that's for one chlorine atom reacting with one electron to form a chloride ion. But we've got 2 right here, so times 2. And this should give us our lattice enthalpy. Delta H of lattice is equal to 642 plus 148. I'm just writing it down more clearly. 242 plus 738 plus 1451 minus, and I'm just going to pop open my calculator for this one. And we've got 349 times 2 is minus 698. Minus 698. So let's check what this gives us in the end. So we got 642 plus 148, 242, 738, 1451, minus 698. So our final value is 2,523. Our lattice enthalpy, delta H lattice, is equal to 2,523. 2,523 kilojoules per mole. And all right, make sure always to circle your final answer so that's easier for the teacher to find. So right here, let's see this. It says theoretical lattice enthalpy is 2,326. Explain the difference between the theoretical and the experimental values. So we've got a theoretical value provided to us right here. And I'm just double checking the textbook. So this is theoretical, and this will be our experimental value. So it must have been through doing an experiment. So right now, our experimental value is much higher than our theoretical value. And why is this? So let me just erase a space down here. So it's a good question. Why is this? Why does theory vary from experimental? And why this is that, theoretical model assumes no outside interaction, I'd say, outside interaction. So it assumes that the molecules and ions act perfectly. And right here we see that, our value, which was 2,523, is greater than their value. So our value just shows that there are more interactions that are occurring, right? If our lattice enthalpy is magnesium chloride solid, and we need to break it up into magnesium in the gas phase in the ionic form and 2 chloride ions. Right, this is a very energy intensive process. We need to put a lot of energy into this. But the ionic model assumes that, a theoretical model assumes that, it's an ideal gas. So it assumes that there's 0 interaction between gaseous ions. But we know that that's not true, that we know that there's some sort of interaction between this. So if we just took, a block of magnesium chloride We started heating it up. As these ions are starting to escape, as this magnesium 2+ and chloride ions are starting to escape, these ions are also going to feel some attraction to the ions in the lattice. They're going to feel attraction. And what the theoretical model believes is that there's zero interaction between this. But we know that that's just not true. But that's why there's always exceptions to the law, and of course different levels of theory. We're covering just a pretty basic theory, but this basic theory, doesn't apply in all experimental circumstances. And let's look at the last one, the last question. Let me just erase this. So last question, D. So I don't think we're going to make it through number 1 through 5 in this video. I like to keep them short, so just come back for the next ones. But the lattice enthalpy of MgO is given in the data booklet. Explain the difference between MgO and MgCl2. Let's check that. Where's the lattice enthalpy? Oops. Nope. Rotate counterclockwise. There we go. Let's try to find some lattice enthalpy. Enthalpies of combustion, oxidation states. Ionization energy, melting points, and boiling points, periodic table. It says it's given in here somewhere. That's not MgO, that's not... Where are the lattice enthalpies given? So maybe they've changed the textbook has kind of changed since the creation of this data booklet, or the data booklet's changed since the textbook. I believe the data booklet was revised in 2017 or 2018, and the book's still from 2014. So of course the data booklet, the locations changed, but we've got this at least given to us here. 3,791, lattice enthalpy of MgO, 3,791, and let's compare that to this theoretical value here, compared to 2,326. And remember, we studied the changes, we studied the attraction and trends in ionic bonding. Remember what we said is that as atoms get smaller, as ionic radii decreases, the bond strength increases, and also as charge increases, ionic bond strength, sorry, I can't really write today, ionic bond strength increases. So those are the two trends that we've talked about, previously in my other videos. So let's look at, what we're dealing with here. We're dealing with MgO, which if we break it down into its ions is Mg2+ and O2-, and we've got Mg plus 2Cl-. So if we compare the charges first, let's check this, 2+, 2-, 2+, 1-. Therefore this has a stronger, larger charge equals increased bond strength, increased ionic bond strength. So larger charge, that could be one reason why the lattice enthalpy is increased. And let's look at the second one. Let's look at ionic radii. So let's do ionic radii of chlorine and ionic radii of oxygen. And these should be provided somewhere in the data booklet. Let's just double check. Maybe they are, maybe they aren't. Enthalpies of combustion, nope. There we go, atomic and ionic radii. This is the exact one that we need. So atomic radius, ionic radius is right down here at the bottom. So the ionic radius of O2- is 140, and chlorine is 181. So we've got 140 and 181. Oxygen has a smaller radius. And smaller radius means a stronger ionic bond. So we've got two things. Lattice enthalpy of MgO is given in the data booklet. Explain the difference. So this has a larger charge and a smaller radius, which increases ionic bond strength. and ionic bond strength, right, then it's harder to break up. If we were to turn magnesium oxide into magnesium ions in the gas phase and oxide ions in the gas phase, we would need to provide a lot more energy because they're attracted to each other a lot more. So okay, we'll come back for the next video. We'll do number 4 to 5 in the next video. 4 to 5 are multiple choice, so they won't take that long. Thank you.